Hello viewers on YouTube. In this video tutorial, we are going to consider going through some practice problems involving the derivative of exponential functions. If you could recall from our proof video, it says that if y is equal to a function of x, f of x, and we have it to be equal to an exponential function e to the power of x, then the y dx, which is simply the derivative of the function, is simply the same as e to the power of x. So basically, what you want to keep in mind is that whenever you want to differentiate an exponential function, regardless of how the structure is, regardless of how complicated it looks, you just want to manipulate it in such a way that it will look something like this, so that at the end of the day, when you differentiate it, you still have that back. Okay, for those who might be confused, by the time we begin going through some practice problems, you would be able to get what I'm saying makes sense. So let's begin with example number 1. To consider the function y that is equal to e to the power of 2x, and let's say we are required to find the derivative of this function with respect to x. So as you can clearly see, what we know is that if it is e to the power of x, then the derivative will be e to the x. But now we have 2x. How on earth can we make this e to the power of x? Well, basically, we can set the entire 2x to be equal to some other variable. So let's consider it to be u. You can use any letter, but it's highly recommended to be using u, as that's the most often used variable to do substitution. So now if u is equal to 2x, so basically it means we now have y to be equal to e to the power of u. Now we can apply our knowledge in general at this point. We can differentiate y with respect to u, and then at the same time differentiate u with respect to x. Upon multiplying the y du and the u dx, we would end up having the y dx, as clearly the u can cancel out and left over is this. So basically the u doesn't cancel because the derivative is not a fraction, it's just that it works, it takes the operation of a fraction. So the product of these two gives us this one. Perfect. So now let's evaluate that. Differentiating y with respect to u, as you can see, this is just e to the power of u. So this clearly means that's still the same as e to the power of u. So it means the y du is still e to the power of u. Perfect. Now what about the derivative of u with respect to x? And the u dx is simply equals to 2. When you differentiate 2x, you just have 2. So basically we need to multiply this one and this one together. And so therefore, that will be the product of this and this one. So clearly, our the y, the x, would simply be equal to 2 times e to the power of u, which is simply 2 e to the power of u. The question is given in terms of x, so we can't leave our answer in terms of a new variable which we introduce ourselves. So we must leave our answer in terms of the variable that is given. So we must replace u with whatever we said it is equal to. So earlier we said that u is 2x, so it means our finest answer is 2 e to the power of 2x. And that is the solution to this problem. Let's consider a few more examples. On to example number 2. So I can actually get it written because I expect you to know the derivative already. So consider the function y that is equal to 3 over 5 multiplied by e to the power of x squared minus 1. So feel free to pause the video and figure this out yourself. So what will be the derivative? Well, just like before, this power is not a linear function. As you can see, it's not to the degree of 1. Understand? At the same time, it's not a monomial. Understand? A monomial is when we have just like x alone like that. Perfect. Binomial when you have up to 2. It's like x plus 2. So that becomes a binomial. Okay, perfect. So now, basically, we can set these to be equal to some other variable u. So let u be equal to x squared minus 1. So this clearly means that y would be equals to 3 over 5 multiplied by e to the power of u. Now, just like before, we can take the derivative of these two equations with respect to the variable they are connecting with or connected to, and then multiply it to get our final answer. So let's evaluate the derivative of u with respect to x. So this clearly implies that the u dx excuse me, will be equals to 2x. But when we differentiate this, we would end up with 2x. Similarly, the y du would be equal. This is a constant. We really don't need to pay attention to that, as it should remain as this. So we have 3 over 5. E to the u is still e to the u. So that's just the derivative. Perfect. Now all we need to do is to multiply these two results, and that gives us about the y dx. So the y dx will now end up being 2x multiplied by 3 over 5 multiplied by e to the power of u. And finally, we got 6 over 5x e to the power of u. If you could remember, or recall vividly, earlier I said that if the question is given to you in terms of x and you made a substitution in terms of u, you must end up leaving your answer in terms of whatever variable is given to you. So we must replace u with whatever you said is equal to, which is x squared minus 1 in this case. So it means our finest answer is 6 over 5x e to the power of x squared minus 1. That gives us the result to this example number 2. So that's it. On to example number 3. So feel free to pause the video and figure this out yourself. So consider finding the derivative of the function y that's equal to e to the power of tan x. So feel free to pause the video and figure this out. So the procedure still remains the same, as our first step would be considering replacing tan x with u. So if u is equal to tan x, then it means our y is now e to the power of u. The derivative of u with respect to x. What is the derivative of tan x? That's simply secant squared x. And the derivative of y with respect to u is still e to the u. So just like before, let's keep on multiplying. So the product of these and these gives us our final answer, which is e to the power, sorry, the y dx. But the y dx is simply secant squared x multiplied by e to the power of u. And leaving our answer in terms of the given variable, we have secant squared x e to the power of tan x. And that's our final result. To example number 3. On to example number 4. So I will suggest you pause the video and try this one out yourself. The function y equals e to the power of sine 4x squared. So feel free to pause the video and try this out. So just like before, let's replace sine 4x squared with u. So if u is equal to sine 4x squared, then it means our y will now become e to the power of u. To differentiate y shouldn't be a problem. However, let's pay more attention to u. U is a sine function. However, the angle is not just a linear function or a monomial that we can just find the derivative just like that. We still have to apply chain rule at this point. So basically, let's consider v to be equal to 4x squared. I'm just trying to make things more simplified. So it means eventually u will now become sine v. Now you should know what it is or what this is. So basically, to get the u dx, because that's actually what we need, to get the derivative of u with respect to x, we would need to multiply the derivative of u with respect to v and the derivative of v with respect to x. As having v to be substituted as 4x squared, that will make u to become sine v. Okay, we actually stated that here. Perfect. So I don't need to repeat that again. So basically, let's find the derivative of v with respect to x and the derivative of u with respect to v. So this clearly implies that the v dx is simply 8x. By the time the 2 comes, and multiply 4, and then reduce this by 1. And the derivative of u with respect to v is nothing but cosine v. Perfect. Now v is 4x squared, but before I replace v with 4x squared back, let me try to multiply. So then we have the u dv, which is simply, okay, I just wrote what's it called? Cosine v. That's the u dv. Okay. So I hope you're not lost yet. So this is the derivative of u with respect to v. It escaped my mind, so I didn't write the u dv, but I write it now. So that clearly signifies that the u dx is simply cosine v multiplied by the v dx. That's simply 8x. And so therefore our final answer would be 8x cosine v, remember, is 4x squared. So that's simply cosine 4x squared. So that's our du dx. Now let's come back to y. So differentiating y with respect to u gives back e to the power of u. And remember, the product of the y du and the u dx gives us the y dx. This clearly means that our final answer for this problem will now be equal to the product of the y du, which is e to the power of u in this case, then multiply by the u dx, which is simply 8x cosine 4x squared. And upon simplifying this, and also upon replacing u with whatever we said is equal to, which is sine 4x squared, then we have our final answer to be 8x e to the power of sine 4x squared cosine 4x squared. So this should be our final answer to this problem. So I hope by now you should be able to evaluate the derivative of exponential functions regardless of how it looks. So let's consider one last example before we end the video. And I would suggest you try this out yourself. However, I in fact changed my mind. So this will be an exercise. Feel free to share your solution with me via the comment section below. So consider finding the derivative of this function y equal to a raised to the power of 2x. Then write the problem a raised to the power of 2x. So should I say anything? I won't say anything. So let me know your solution in the comment section below. Thanks for watching. See you in the next video. Bye for now.